Hello, welcome to Chapter 1, Lesson 1, What is Electromagnetic Radiation? So, the contents of this lesson, we're going to look at what is electromagnetic radiation, and we're going to look at the electromagnetic spectrum and its uses. So, electromagnetic radiation is a type of wave called a transverse wave. What this means is that the direction of travel or the direction of propagation of the wave is at right angles to the direction that the energy moves in. So it's an electromagnetic wave, which means it's constructed from an electric field and a magnetic field. So both an electric field and a magnetic field is a sinusoidal wave in its own right, and what you get in an electromagnetic wave is these are synchronized together. So the direction of propagation, the electric field and the magnetic field all have to be at right angles to each other. They are all mutually perpendicular. And you can show this nicely on a set of X, Y, Z axes, as you can see at the bottom. So we've said that X is our direction of propagation, our direction of travel, which is the V arrow for velocity. We've added in our electric field, so you can see that sinusoidal wave, and you can see that it's perpendicular to the velocity. And if we add in the magnetic field, and that's coming in and out of the page to you, so that is perpendicular to both the electric field and the direction of propagation. And you can see that those sinusoidal waves are nicely lined up on the electric and the magnetic field. So you end up with a set of three axes. So we've got direction of movement, we've got an electric field, and we've got a magnetic field. So they're all moving in separate directions. And the really useful thing about these transverse waves, these electromagnetic waves, is that we can put energy into them and we can send signals through them, which is a lot of what we use in the space industry. So the electromagnetic spectrum and its uses. So the electromagnetic spectrum is huge. It covers a wide range of frequencies and wavelengths. As humans, we've kind of split this up. It's exactly the same wave. It's an electromagnetic wave all the way. It's a transverse wave. Nothing changes about it other than its wavelength and its frequency. We have different uses for different sections. So at the radio end of the spectrum, we've got the long wavelength with the low frequency. At the gamma ray end of the spectrum, we've got the short wavelength with a high frequency. So we'll look at this in another lesson, why there's this inverse relationship between wavelength and frequency. The other key thing about electromagnetic waves is they all travel at the same speed, because it's all the same wave. And that speed is the speed of light, so it's 2.99 times 10 to the 8 meters per second. So the bit that we're most interested in the space industry is actually the radio and the microwave section. So we use these for space communications, radar, etc. It's our favourite bit of the spectrum. So we're at the long wavelength, low frequency end. The only thing I think to just keep in mind is that we don't think of radio waves or microwaves as being particularly dangerous. We use microwaves every day. We listen to the radio all the time. This is all fine. And that's true in the way that we have them set up in our everyday life. However, when we're dealing with them in the concentration that you're often using in the space industry, they can still be damaging. So you have to take care over doing this. So you'll find there's a whole module coming up on actually looking at how to safely use these radio frequency and microwave radiation. The gamma ray, we all accept we have to be very careful with in all situations. So, conclusions. What have we learnt in this lesson? We know that an electromagnetic wave is a transverse wave. It's made up of oscillating electric and magnetic fields. We know that the electromagnetic spectrum is a continuous spectrum, and we've sectioned it up so we have different uses for it. All electromagnetic waves travel at the same speed, which is the speed of light, 2.99 times 10 to the 8 meters per second. And there's this inverse relationship between the frequency and the wavelength. Okay, so lesson 2, we're going to move on to look at other properties of electromagnetic waves that are really interesting for the space industry. We're going to look at magnitude, phase, and polarization. Hope to see you there soon.